Good morning, students. Welcome to online teaching session of Academic World School, Devendra. This is third chapter of Mathematics of class 8. The name of the chapter is Understanding Quadrilateral, and this is the first lecture of this chapter. So, in this chapter, Understanding Quadrilateral, today, what we are going to learn are definition of polygon, classification of polygon, diagonals, and the formula to find diagonal, convex and concave polygon, regular and irregular polygon, angle sum property of polygon, especially angle sum property of quadrilateral, interior and exterior angle. Okay, and formula for interior and exterior angles. So these things we are going to study. See, quadrilateral we have learned in our previous classes. Okay, so first we will see what is polygon. See, the word polygon the polygon word as derived from two words, poly and gon. Poly means many and gon means size. Many size. Okay. So here, when a closed curve, now we have studied about curves. There are two types of curves. One is the open curve, another is the closed curve. Right. So a closed curve has many sides. Okay, we are talking about sides. Side means, okay, a line segment. Right, a line segment. So a closed curve having many sides is called polygon. Right? A closed curve having many sides is called polygon. Okay? And if we categorize polygons, okay, on the basis of their side, right? Polygons having many sides, closed curve having many sides, or having many line segments. Okay, so we categorize polygons on the basis of their sides as well as on the basis of their angles. So first we will talk about classification of polygons on the basis of their sides. So on the basis of side, see, gon, as I said, that this tells that side. Okay, so if a closed curve having 3 or more than 3 sides, okay, remember that now I am going to be very specific about this. As I told you, polygons having many sides. Now how many sides it should be? At least the minimum number of sides to become a polygon. A closed curve will be polygon only when it has at least 3 sides. If it has less than 3 sides, it's never going to become a polygon. So to become a polygon, to be a polygon, there should be at least 3 sides. Okay. So this is how we are going to categorize a polygon. So we define polygon specifically a closed curve having 3 or more than 3 sides. A closed curve. We are going to be very specific about the definition of polygon. A closed curve having 3 or more than 3 sides is called polygon. So what kind of closed figure will have at least 3 sides? Triangle. If it has 4 sides, it's a quadrilateral. If it has 5 sides, then it's a pentagon. If it has 6 sides, then it is hexagon. Okay, 3 sides, triangle. 4 sides, number of sides. 3 sides, here 4 sides, here 5 sides, here 6 sides. If a polygon is having 7 sides, then it's a heptagon. Okay. If it has 8 sides, then it's a octagon. If it has 9 sides, then it is nonagon. And if it has 10 sides, then it is decagon. Now 3 sides, triangle, 4 sides, quadrilateral, 5 sides, pentagon, 6 sides, hexagon, 7 sides, heptagon, 8 sides, octagon, 9 sides, nonagon, and 10 sides, decagon. Now you will be wondering that after 10 sides, what we will name? So actually after 10, after 10 means if a polygon is having more than 10 sides, if a polygon is having 11 sides, so what we are going to call? So actually for after 10, we write that if a polygon is having 11 sides, so we write here 11 gon. If it has 12 sides, we write here 12 gon. If it has 13 sides, then we write 13 gon. Okay? Right? You understood that? This is the classification of polygon on the basis of number of sides. Right? 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, and so on. 10 sides decagon, and if more than 10, we write 11 gon, 12 gon. It's with number, how many sides it has. Okay, that number of sides, and we will use the word gon. Suffix you can call it. Okay, gon. So 11 gon, 12 gon, 25 gon, or 99 gon. If a polygon is having 99 sides, so we will call it 99 gon. This is how we classify a polygon on the basis of number of sides. Now, each polygon has two important, say that its element. Okay, two important elements. one is the vertex. One is the vertex, another is the diagonal. So we have already studied about the vertex. Vertex is a point. Vertex is a what? Vertex is a point where two line segments meet in a polygon. Okay? In a polygon where the two line segments meet, that point is called vertex. For example, if we take a triangle, right? So this is and this is called vertex, because see that at this point this line segment and this line segment is meeting, at this point these two line segments are meeting, at this point these two line segments. So this is called vertex. Okay, this is called vertex. Now suppose there is a condition in which the two vertices are joined by a line segment. Two vertices are joined by a line segment. Okay, see here we cannot get that, but I am going to make another polygon in which it is possible to join two opposite vertices. So four sides, it's a quadrilateral. So this is a vertex and this is a vertex. Suppose we join these two vertices. We are joining these two vertices. So these vertices will be joined with the help of a line segment, right? So this line segment, the line segment which joins the line segment which joins two opposite vertices is called what? Diagonal, right? The line segment which joins two opposite vertices, like now see, these are the two opposite vertices, so we have joined by line. So this is a diagonal. Now here two opposite vertices, if we join them, so this is a diagonal. So this line segment is called diagonal. Okay, this line segment is also called diagonal, right? So diagonal is nothing but a line segment. Remember that diagonal is a line segment which join two opposite vertices, right? Now we are going to find number of diagonals in a polygon. Okay, in a polygon, how many diagonals are possible? Okay, so there is a formula here to calculate that. Okay, number of diagonals in a polygon. Okay, number of diagonals in a polygon will be equal to n into n minus 3 upon 2. See that? N into n minus 3 upon 2 now. Where n is number of sides. Where n is number of sides. Right? So let's find out the number of diagonals in different types of polygons. We will start from triangle. That in triangle, how many diagonals are possible? So we know that in a triangle there are 3 sides. So in a triangle there are 3 sides, which means the value of n will be 3. So number of diagonals will be, so this is the formula, n into n minus 3 upon 2, right? So the number of diagonal, what is the value of n for triangle? It's a 3. Okay, 3 into 3 minus 3 by 2. 3 into 3 minus 3, 0 upon 2. So 0 by 2 equal to 0. See that? In a triangle, the number of diagonals is 0. Which means in a triangle there is no diagonal. Now, next polygon is what? Next polygon is quadrilateral. So in a quadrilateral, how many diagonals are there? In quadrilateral, number of diagonals. So we use the same formula, right? So in a quadrilateral, how many sides are there? 4. So value of n will be 4. So we use this formula. So it's 4 into 4 minus 3 by 2. So 4 into 1 by 2. So 2 into 1 is 2. So number of diagonals in a quadrilateral, how many? 2. Let's find out number of diagonals in pentagon. Okay, number of diagonals in pentagon. So number of diagonals, so number of sides will be 5 in pentagon, right? So number of diagonals will be n into n minus 3 upon 2, which means 5 into 5 minus 3 by 2, 5 into 2 by 2, 5 minus 3 is 2, now 2 cancel, we get 5. So number of diagonals in a pentagon is 5. Number of diagonals in octagon. Number of diagonals in an octagon. So in octagon, number of sides will be 8, right? So number of diagonals will be n into n minus 3 by 2, which means 8 into 8 minus 3 by 2. Now 8 into 8 minus 3, 5 by 2. If you cancel that, 8 by 2, you get 4, 4 into 5, 9. So number of diagonals in an octagon will be how many? 20. So this is how we calculate number of diagonals in a polygon. Remember, number of diagonals in a polygon is n into n minus 3 upon 2, where n is number of sides in a polygon. Now, we know that if we categorize polygon, earlier we categorized the polygon on the basis of number of sides. Now we are going to categorize polygon on the basis of angles inside it. Means on the basis of interior angles. So on the basis of interior angles, we will see there are two types of polygon: convex polygon and concave polygon. Now, convex means such polygon whose interior angle, okay, whose interior angles are less than 180. Okay, convex polygon, such polygons whose interior angles are less than 180. You can say each interior angle, such polygon whose each interior angles are less than 180. That polygon is called convex polygon. But if any interior angle is more than 180, if any interior angle is more than 180, that polygon is called concave polygon. So we can see that the polygons which are not convex, the polygons which are not convex, they are concave polygons. Right. So, for example, now let's see the example of convex polygon. Remember that what I told for convex polygon, that each interior angle, okay, each interior angle should be less than 180. So, for example, triangle, see that each interior angle is less than 180. So this is a convex polygon. If you make a pentagon, okay, so here also if you measure each interior angle, the angles are less than 180. So this is also a convex polygon, right? So we have to keep in mind what the one important thing, that each interior angle should be less than 180. Then it will be a convex polygon. But if any of the interior angle is more than 180, that polygon is called concave polygon. Okay, so we write here one or more than one interior angle is one or more than one interior angle is more than 180 degree, then such polygon is called concave polygon. Okay, so to be a concave polygon, the interior angle should be one or more than one interior angle should be what? The measure of that interior angle should be more than 180. Now I will make a diagram for this, then you will understand it very easily. So let's see now. See that this interior angle, okay, this interior angle is more than 180. So this polygon is what? Concave polygon. Okay. So you can draw different polygons like this also. In which at least the one angle is more than 180. At least one more angle is 180, then it is concave polygon. Okay. So remember that convex, each interior angle should be less than 180. Convex, each interior angle should be less than 180, and concave, at least one interior angle should be more than 180. Now let's come to the next type, next categorization of polygon, that is regular polygon and irregular polygon. So regular polygon means regular polygon. First we will talk polygon. So regular polygon says that the first condition that it should be equiangular, and the second condition says it should be equilateral. So two conditions. There are two conditions by which a polygon can be a regular polygon. The first, equiangular, means angle should be all angles, the measure of all angles should be equal, and equilateral means measure of all sides should be equal. Okay, such polygon is called what? Regular polygon. Okay, a polygon in which it's all interior angles. Remember that whenever we are talking about just angle, then we need to understand that they are the interior angles. Okay, so all the interior angles should be equal. Then measure of all the interior angles should be equal, and the measure of all sides should be equal. Then such polygon is called regular polygon. For example, square. Okay, in square you will see that the measure of each angle, each interior angle is 90 degree, and all the sides are equal. All sides are equal. So square is a regular polygon. So can you tell me another example for regular polygon? Yes, you got it. Equilateral triangle. What? Equilateral triangle. In equilateral triangle also, since each angle is 60 degree, right? So that means the measure of each angle is, each interior angle is 60 degree. That means all angles are, or all interior angles are equal. And in for sides, since that's why it's named equilateral, means all the sides equal. So all sides are equal, means equilateral triangle is also a regular polygon. Okay. Now what about rectangle? Is rectangle a regular polygon? See, let's see it. Is rectangle a regular polygon? So for rectangle, if you see that, we will get each angle 90 degree. Fine. We will get each angle 90 degree. Since one angle is 90 degree, so by the properties we can get each angle 90 degree. But the second condition by which is necessary to be a regular polygon. Second condition, are the all sides equal? Are the all sides equal? No, only the opposite sides are equal. Only the opposite sides are equal, which means this is equiangular but not equilateral, which means this is not a regular polygon. This is not a regular polygon. So a figure which is a polygon which is not a regular polygon, that polygon is called irregular polygons. A polygon which is not regular polygon is called irregular polygon. For example, rectangle. For example, scalene triangle. For example, say kite. Okay. So to be a regular polygon, okay, its it must have all angles equal and all sides equal. Okay, right? Now you can write more examples of regular polygon, like we can say regular pentagon, regular hexagon, regular heptagon, right? So when we are talking regular pentagon, which means its measure of all interior angles same and the measure of all sides are same. Okay, so this is how we classify polygons. Now the two important properties are left, which we will learn in the next lecture, that is angle-sum property of polygon and interior and exterior angle property of polygon. The assignment related to this lecture will be uploaded on the ERP. Download the assignment and please do it positively. Thank you.